All right, so sadly, that was the only two things that they gave me that were congruent. So now we gotta look at the diagram, okay? We have two triangles, ACB and ABD, right? Well, if I notice, they share a side, right? They both share side AB, okay? And AB is congruent, so I can make a statement of congruency. Line AB is congruent to line AB. And we go back to our reference sheet. So, reasons for congruent sides. They didn't tell us that those were congruent, okay? So it wasn't given. There was no definition of midpoint because there was no midpoint, and they told us they didn't tell us there's a midpoint. So our only option left is reflexive property, where a side is congruent to itself. And that's what's happening here. AB is congruent to AB due to reflexive property, okay? And anytime they share the same side, you'll have reflexive property, okay? And that's it. How many pairs of sides do I have that are congruent to each other? 3. So therefore, I just proved that triangle ABD is congruent to triangle ABC. I wrote it backwards than what was right there, but same thing, okay? And I proved that due to side, side, side. Because I found that 3 pairs of sides of a triangle are congruent, okay? Now let's talk about a little bit of SAS, okay? SAS, which is side angle side congruency theorem, okay? It says if two sides and the included angle of one triangle is congruent to two sides and the included angle of another triangle, then the two triangles are congruent. That's even more confusing sounding than SSS, right? So let's put it into words, okay? If we look at the diagram, it tells us that AB is congruent to line DE, right? So line AB is congruent to line DE, okay? If we look, what's next? It's an angle, okay? So angle B, let's just switch my color there, sorry. Angle B is congruent to angle E, because it's given. And lastly, they told us BC is congruent to line EF. So line BC is congruent to line EF. That is an E, by the way. So we have a side, we have an angle, and we have a side. And if the side is congruent to the other side, the angle is congruent to the other angle, and the next side is congruent to the next side, then triangle ABC is congruent to triangle DEF. And remember when I was talking about the reference sheet, the order matters, okay? It has to be SAS, okay? Can't be SSA, because backwards, that's a really bad word, and we don't do bad things in geometry, okay? We stay away from bad things. It's also, like, the main reason why we can't do SSA is because, let me find it again. So, SSA doesn't work because the unknown side, the third side, could be located in 2 different places. So that's why SSA is not congruent, okay? So again, highlight this. Included means the angle between the sides. So it has to be SAS, okay? It has to be an included angle. So let's start doing a truth table on it. So we are given that line AB is congruent to line CB. And if you look, that's my first statement. And my reason is what? Given. They told us it was a true, so we believed them, okay? And once we do that, we go to our diagram and write it, okay? We write that it's congruent, and that one's congruent. Then we see that line BD bisects angle ABC, okay? So that's my second statement. Line BD bisects angle ABC. The reason why is because it's given. They told me, so I believed it. Well, let's talk about bisects, okay? So line BD bisects angle ABC, which means line BD is an angle bisector, okay? Bisector means 2 sections. So angle bisector means angle split into 2 congruent segments, okay? So this is my angle bisector. Let's switch it to blue. And this is the angle that's being split in half. That means we go right here. This angle, which is ABD, is now congruent to this angle, which is DBC. Okay, so now those are congruent to each other. And if you look at my third statement, it is that. It's why I just said ABD is congruent to angle CBD. And why is that? You can go back to your reference sheet if you want, if you don't know. So we go back to our reference sheet, reasons for congruent angles. Definition of angle bisector. Okay, because we know that if we have a line bisects, that's an angle bisector. So definition of angle bisector. Okay. Now, they give me nothing else, right? But if we look, there's two triangles, right? And don't they share one side, right? They share line BD, okay? So that means that line BD is now our second congruent side, okay? And when a side is congruent to itself, that is called the reflexive property. Okay. So again, anytime you have a side that is shared by the triangle, it's a reflexive property. So now we have a pair of congruent sides. We have an angle and then another congruent side. And the angle is in between the two sides. So we just proved that triangle ABD is congruent to triangle CBD by SAS, side angle side, or aka SAS. Okay. Now let's talk about number 7. Let's switch some colors up. All right. Again, we look at what we are given. Okay. We are given that line HI is congruent to line JG. And again, your first reason will always be that's given to you. Okay, so on your test, your first reason will always be given. It's a little like answer right there. So HI is congruent to GJ. Okay. And then it tells us that HI, remember this symbol? What does it mean? It means parallel lines, okay? So line HI is parallel to line GJ. So that's my second statement, and again, it's given. And now we have to mark that on our diagram, okay? And how do we mark parallel lines? By little arrows. But some of my students say triangles, which I guess they do look like triangles. So, when we have parallel lines, we get to use something really helpful that we learned in, was it Unit 3? Which is called angle relationships, okay? So therefore, HI is parallel to GJ, which means that this line right here, HJ, is what? It starts with a T. It's a transversal, okay? So we look at statement number 3. It says that angle GJH, so it's this angle right here, is congruent to angle IHJ, so this one right here. Okay, so let's mark that. They are congruent. Again, this is GH. Oh, I'm going to use a different color than that. This is GJH, and this is IHJ. And they're congruent, okay? Why are they congruent? Well, if I look, again, this yellow line is the transversal, okay? Well, these angles, are they on the same side of the transversal? No, they're not. And when we have angles that are not on the same side of the transversal, they're alternate angles, okay? And these are alternate interior angles because they are in between the two parallel lines, okay? So that's literally our reason. Angle GJH is congruent to angle IHJ because they are alternate interior angles, okay? Just like that. erase this so we can see a little bit better. Okay. Now, my next statement is HJ is congruent to JH. These are two triangles, and they both share a side, okay? Which means the side is congruent to itself. So that is, why is that? It's the reflexive property. So, why is triangle GJH congruent to angle IHJ? Well, we have pair of sides are congruent, then we have an angle and another side, right? So side, angle, side is why it's congruent. And it's that because the angle is in between the two lines, okay?